Hey, future physicists, what we want to talk about today is static equilibrium. So static equilibrium. And what that means is we're dealing with objects that are not moving. So static means they're not moving, equilibrium meaning that all of the forces cancel out on those objects. So in the first problem we look at, we have a classic sign problem, like you're walking around downtown. You have this piece of metal that's holding the sign out, and the sign is hanging over what you're walking. So like the door might be over here, and you would be standing underneath walking in or out of the screen here. This piece that's holding it out is what we would call the boom. And this piece that is the string or steel cable that's up here, we're going to call the tie rope. And then over here is your sign that is hanging off of the end. So the first thing we want to do is draw a force diagram. I'm going to have the sign that is pulling straight down here, and it's going to have a certain weight or a force of gravity. That weight is going to be the mass times the 9.8. And when we do that, we get 882 newtons. Now, the second force that we look at will be the boom, and think through that the sign really wants to fall towards the wall, so the boom is holding the sign away from the wall. That's going to be the boom. And then the third force that we have is the tie rope is really pulling this up at an angle. So here's our tie rope pulling it at an angle. Notice that our weight is up and down, our boom is side to side, but our tie rope is not. So if I break the tie rope up into components, then I'm going to have a tie rope Y, and I'm going to have a tie rope X. And when we do that, that in essence gets rid of that guy. Now I can look at this and say, hey, if this is an equilibrium, then doesn't the tie rope Y have to equal the weight, which is going to be 882 newtons, right? And then we can look and say, well, the tie rope X is going to have to be equal to the boom. So how do we put those together? If I redraw my tie rope here, and I know that this angle is 37.8, then I can say, well, it looks like the opposite over the adjacent. So I'm going to say the tangent of 37.8 is going to be equal to the Y value, which will be the 882 over the X value. And when you solve for the tie rope X, you end up getting a 1137 newtons. And so that's how you would find the boom value, which will be the X component, and the tie rope value, which is the Y component. Now, in the second type of problem we're going to look at, this would be like if you were to hang a picture in your house, and we can think through it as the picture is going to have a certain weight that is pulling straight down. It's going to cut this angle in half, so this will be an 82 degrees, this will be 82 degrees over here. And you can picture that each of these strings are pulling up, in essence, pulling this way and pulling this way, and together they have to create an equilibrium that is equal and opposite to that force of the weight, right? So, or another way to think of it is, if I break up that value into an X and an X, those two X's have to be the same. And if I break them up into a Y and a Y, then the two Y's together have to be equal to the weight. So the easiest thing that I can do is, because my angle gets split evenly, I can say that those two Y's are going to be equal. So I can say then that 2 times the Y tension is going to equal the weight, which means that the Y, one of the Y tensions is going to be half of the weight. So I probably need to do that next. I'm going to take this and times it by 9.8. When we do that, we get a force of gravity of 476.3 newtons. So I'm going to take 476.3 divided by 2 and end up with a Y value of 238.14 newtons. So that's my Y value for that. Now, the next thing that I could do is I want to find the X value, and I say, oh, if I look again at the tangent, so the tangent of theta, if this is my theta, my opposite is going to be the X. So I'm going to say Tx over Ty. So I'm going to say the tangent of 82 is equal to Tx over that 238.14. Then I can find my X component is going to be 1694 newtons. Now, there are two things that I can do from that. I could do the Pythagorean theorem to find out what the actual tension left, tension right is. So I could say 1694 squared plus 238 squared, square rooted, and that'll give me a TR, which is equal to TL because they are split evenly there. And that gives me the 1694 newtons, which is the answer. I'm sorry, not 1694. That gives me the 1711 newtons, which is the answer. 1694 was the x component. The other thing I could do is I could use SOHCAHTOA using the sine or the cosine for either one of these to find that diagonal or the hypotenuse. The last one that we're going to look at then is a stoplight problem. So I have a stoplight here that's hanging out in the middle of the road. It's very, very similar to the last two. So I could say, hey, there's this pull of gravity coming down. This tension right is pulling up at an angle. Tension left is pulling up at an angle. And together, those two x's have to cancel out. And the two y's together have to create the equilibrant that will cancel out and equal and opposite force to that. So again, my angles, I'm going to split and say, well, if this whole thing is 109, that means this inside one is 71, this inside one is 71, right? And let's see, we can say that TLX is equal to TRX. We can also say that TLY plus TRY is equal to the weight. Because the angle is split evenly, then these two have to be equal. So I could just divide the weight by 2. So let's see, the weight is 100 newtons. So I can say that TLY equals TRY, which equals 50 newtons. So here are two 50 newtons. 50 and 50 newtons. From there, we could look at that again and do sine, cosine, tangent. So if I want to find that's the y value. If I want to find the x value, then I can say that the tangent of 71 is equal to the opposite, which is the x value, over the y value, which is 50. And that tx value then is going to come out to be 145 newtons, which are each of these guys. Again, they're both equal because the x's have to cancel out and the angles are equal. And then lastly, again, we could either use sine and cosine to find the diagonal, or we can do the Pythagorean theorem where we would say, hey, if the one side of this is 50 and the other side of it is 145, and the hypotenuse then has to be from the Pythagorean theorem, and doing that, we're going to end up with 154 newtons is the TR, which is also equal to TL. So both of these end up being 154 newtons. So again, major concept with static equilibrium is that all of the forces cancel out. So whenever you're looking at all of the up and down forces, the up ones have to equal the down ones, and all of the left ones have to equal the right ones when you're talking the side-to-side parts to that.